so we're going to be making a cone, and when making a cone, here I'll just make a little drawing of a cone here. So let's pretend that's the base circle, and here's the body of the cone going up. Okay, notice you get this nice right angle triangle made with the height and the radius and the slant height. Okay, so I'm going to call this A, this is going to be B, and my slant height is going to be C. And we know the A is 3 centimeters. Okay, that's given. And the B is the height, which is 10, and that's given. We don't know the C, so we have to figure that out. So we're going to use Pythagoras' theorem. A squared plus B squared is equal to C squared. So that gives us 3 squared plus 10 squared is equal to C squared. That gives us 3 squared is 9 plus 10 squared is 100, which is 109 is equal to C squared. So the square root of 109 is C, and that gives us 10.44 something, something, something. But I'm going to use 10.44 is going to be my slant height. Okay, we also agree that when we unfold this thing, we get a shape that looks like a sector. Okay, so you get a nice sector that looks something like this, and then you have the circular base. Now the circumference of the circular base is equal to the arc length of that sector. Okay, we know that they are the same. All right, the reason we know they're the same is we can see it on the cone. This is the sector, right? This is the arc length of the sector. And this is your circumference of your circular base. So you know that they are the same thing. Okay, if that is true, we can set up a nice equation. We can say that the arc length is equal to the circumference of our circular base. Now the arc length is going to be n degrees out of 360 times the total circumference of the arc times 2 pi. And I'm going to call this the slant height. I'm just in this diagram. I'm going to call it big R, and I'm going to call this little r. Okay, times 2 times pi times big R is equal to the circumference of the base, which is 2 pi little r. Okay, I'm going to get rid of this 2 pi big R by dividing both sides by 2 pi big R. Like that. And that will totally cancel here. My 2 pi's will cancel. And we end up getting n degrees out of 360, which, by the way, is the fraction of the circle that we're dealing with, is the same as little r over big R, which is a nice and important formula. I'm just going to put that in a box. All right. So now, we know what little r is. We know what big R is. So n degrees out of 360 is equal to my little radius, which is 3. My big radius is 10.44. And then I can just, to get rid of the 360, I can multiply both sides by 360. And it's calculator time. So n degrees is, here I'm going to write over 360. And multiply this side by 360, multiply the other side by 360. And those 360s can't cancel, so n degrees is, and it's handy dandy calculator time. So we have 3 divided by 10.44 times 360, and that gives us 103.45 degrees. Okay, and there's our answer. That's our central angle. That's what we're looking for. So now that we have our central angle, we can draw our arc, we know the radius, and away we go. So, my arc length, not my arc length, sorry, the radius is 10.44. So I'm going to adjust my compass to 10.44. So I put the point on my 0. There's 10, there's 10 point. Okay guys, back to the recording. All right, so we know we are measuring 10.44. Now the 10.4, that's easy enough to get, but 10.44, I don't think we can be that accurate. We can get to 10.45 maybe, but that's about it. Okay, so I'm going to make an arc that has a radius of 10.44. Okay, and there it is. I made one mistake. I did not mark my starting point. Always make a little dot to mark your starting point, otherwise you lose it. Okay, so I'm just going to make this the start of my angle. And then my angle that we figured out was 103.45 degrees. I'm going to measure that. Okay, so 100, 1, 2, 3.5, let's say. Okay, and there's the central angle. Okay, so that's 103.5 degrees. Okay, so now we need to make the circle, which has a radius of 3. I'm not going to make it attached, because I think we saw with the cylinder that when you're making them attached, they're only attached by some infinitely small point, which you might as well not have it attached at all at that point. So I'm setting the radius to being 3, so the diameter will be 6. Okay, and notice I'm not spinning the paper. I'm leaning the compass in the direction I want it to rotate, and I'm turning the compass. All right? Can you guys see those lines, by the way? Sure you can. Okay, so now it's time to cut them out. Rachel, I'll need my scissors back, please. Okay, now this is what I was talking about. When you're cutting stuff out, cut it about 3 or 4 millimeters too big for the first pass. You're going to be a lot more accurate if you do it that way. So you cut it too big the first time across, and then you do your fine cutting later. Okay, to cut out my circles, I'm not going for accuracy at first, and then we're going to cut exact. So I'm going to make sure that I'm cutting very close to the hinges of the scissors, and that I always am cutting right on the ink. Okay, just making very small little bites each time. Okay, and if you do that, you're more likely to be accurate. And if you start to cut and you realize you're making a mistake, stop. And then correct. Okay. And it's better to make a mistake on the outside of the circle than on the inside of the circle. Okay, So that's the circle. Now, if you want, you can score this and just bend it back. And then you can do the same with that side and glue them together. But I'm just going to use tape, so I'm not going to worry about that. Okay, this is pretty thick cardboard. Now, generally you want to make your cone with thinner cardboard because it's easier to bend. Because we're going to have some trouble bending this. Okay, so now when we go to bend it, what I'm going to do is I'm just going to use the edge of my desk here. And I'm just going to start by bending it, but keeping the point always right here on the corner. Okay, and then bend it. And you're just going to go back and forth, just trying to get it to bend along the radius. Okay, remember this is a fraction of a circle. It's a sector, okay, and this is the radius, right? So that's where we're trying to get it to bend. I'm going to start off trying to bend it like, about 15 degrees or so. Okay, and I just keep doing that. Okay, it's very important that we get it to bend all the way up to the top. Back and forth like that. Always try and keep the point in the same spot. Okay, so that should do it. And make sure the ends are bent nicely. Okay, so that should do it. Now I need to get some little pieces of tape. Points here. Okay. And we want to make sure that the curve here is transferred across the whole cone, not just in this one spot, but across the top. So you have to make sure it bends very well. Okay, and I'm also going to tape it on the inside. Okay. Just taping all the way up the cone. Okay. Okay, I'm just flattening this part. Okay, so that's almost perfect. Okay, now to glue the circle, or tape the circle on the bottom. And so this should fit exactly, okay? because of all the math we did. And so I'm just going to start off taping it in one spot, and I'm just going to tape it in a few spots, and then we'll get some parts that like here that stick out, and some parts that stick in. And you will see that as we go around the circle, as long as we're consistent, that any parts that stick out, we tape down. It'll push out the parts that stick in. Okay, like that sticks out, so I'm going to tape it. Okay, and I'm just going to go around the circle doing that. Here's a part that sticks out. So any parts that stick out, tape them down. Very simple. Okay, so I'm just going to continue doing that. Down. Whoops, you can't see what I'm doing. Okay. So any parts that stick out, push them in and tape it down. Okay. I might be able to go in a little bit further. And notice it's pretty close to perfect. And there is my cone. Okay, a lot of small pieces of tape, and it's pretty close. Okay, so I'm happy with this cone. It does what it's supposed to. And here I'm just flattening it a little bit. Now to get it perfect, if you wanted to, you could put a whole bunch of little circles inside. Okay, at the right spots, but that would involve a whole lot more math. But there we go. Cone. Have a good day.